Um, we never quite finished going through the questions that were on the sort of tutorial sheet. So I'll run through those fairly quickly, or swiftly, I should say. And then we'll move on to the exam papers that are online. And for those of you that are very quick off the mark, about 15 minutes ago I did actually put on the structure of this year's exam paper. So you can see what question 11 is going to be and the actual structure of the marking scheme for the other questions. Question 11 won't be a surprise. Alright, it's not a surprise if you looked at the exam papers before. So I just thought I'd mention that at the start, that it is now online. But let's see where we got to. I think we got to about here. I think we did the first lot of aerial triangulation questions, and where there was a second and third lot. There is a little bit of a repeat amongst these questions, because I did pull them together from two or three different slides and presentations and things. So you will find I've repeated. They're not necessarily exactly the same, but very, very similar. So we shouldn't need to spend too long on them, I don't think. But there are a few questions, like the first one, where you might feel that we haven't really answered the question entirely, and in the sense that I haven't specifically answered the question. What I've done is perhaps alluded to it as we've gone through the class. So I'm just trying to I'll master this smartphone one day. Anyway, yeah, so I'll go through these and we'll see how we get on, and see what time we've got. And if anybody's got any questions, then clearly I'm happy to answer them. Oh, before I forget, I will not be in the university from today or after the class until the 6th of January. Right, so that basically it's for the next, whatever it is, 3 weeks. When I return, I will be only working on Tuesday, Wednesday and Thursdays. Right, so that's a slight change in the pattern of working. So for Tuesday, Wednesday and Thursday, just in case you've got any questions once we start term time. Yeah, so that's largely during term time. That will start. So, why is a model section adjustment so computationally efficient? Well, if you remember, the model or section adjustment was based on the example I gave is having 4 stereo models joined together like this, so that we could write a piece of software, a computer program to join 4 stereo models together. Then once we join those 4 together, they would be in a single coordinate system based on a choice that you've made as to what that coordinate system would be. And then that becomes a fixed set of coordinates. A fixed set. So we could then take that 4 stereo models, and then we could take another 4 stereo models that we've all joined together, and oops, I'm a little bit big this time, and then another set, and another set, and we could join up those 4 sets of stereo models. So once again, drawing it a little bit smaller, we end up with 4 stereo models joined together. But this time, sorry, they're not stereo models, they're what we call sections. And that's why the question says model or section adjustment. So these are 4 stereo models, therefore, and therefore. Now we've got 4 that we could join together again. So now we've got 16 stereo models, all joined together, now as a single coordinate system. A single coordinate system that we can now call another section. All those coordinates are unified, they're all together, and they are considered as one group or section of coordinates. And we could do the same thing again. We could take all those and we could end up with four lots of those. I can draw it again and again and again and again. And you can see this repeating of these 4 sets of models, or 4 sets of sections, and then 4 sets of the 4 sections, and then 4 sets of the 4 sections. It's that repeated process. And it's all based on one relatively straightforward and simple computer program, because you're just dealing with 4x4s. But quite clearly, you very rapidly increase the number of strips and models that you are joining together. So that makes it very computationally efficient, because it's the building of these things together. This is considering a block of 2 strips of 4 photographs with 3D control points in each corner and height points being used as tie points. At the start and end of the strips, tabulate the number of unknowns and equations formed by the model adjustment. Assume only a planned solution. See the following figure. There's the following figure. So this is very similar to the one that's in your notes. All it is that I've added another photograph in the middle here. So it's just a little exercise, if you feel inclined, of writing out those equations, just so that you get an idea of really a bit deeper understanding of how these things fit together. So again, you could write a computer program for 6 by 2 strips of 6, couldn't you? It is a lot easier for those of you that have never written really more involved and sophisticated software. It is a lot quicker and more efficient if you can write software that is not very flexible but will solve a particular problem, because it's when you introduce flexibility that software becomes very, very demanding in terms of its writing.
So, phase 5, for example, 5 sections.
Pardon? We've done the one by of 4 photographs, haven't we? 2 strips of 4 photographs in class. Yeah?
Means it all 5, but we are doing number 1 to 6, but I think we skipped number 1 to 5.
No, we did them last week, I think, didn't we? The first 1 to 5. Did we? Yeah, did we not?
The first 1 to 5, but the second 1 to 5.
Did we only do the first question here then? Is that what you're saying?
Are we doing this one? Because we haven't done this one.
Oh, wait a minute. Did I step too many then? That's the first lot I think we did last week.
Yes.
I jumped those, didn't I? Okay, we'll come back to those 5. Thanks for spotting that. So that's a little project if you want something to do on a Christmas morning or Boxing Day or whenever it takes your fancy. Actually, the next question is a repeat of the one before, isn't it? Almost. Yeah. So the second one. This one here is talking about the functional solution. This one is about the model adjustment. So this one is about this, and this one is about using the collinearity equations. Alright, so it's just saying to you, we did an example in class. Now if you wanted to follow through and get a little bit better understanding by writing it. Describe how a bundle aerial triangulation. This would be, I would consider it a long question. The bundle aerial triangulation solution, if you remember, uses the collinearity equations. So we have to, in fact, there's quite a nice, I say that, I suppose I would say that, I suppose. There is the flow diagram in your notes that goes through that process. Just trying to think where it is. I think it's in here. Yeah, here it is. Which gives an idea of the way the collinearity equations are solved. That question is probably a little bit bigger than this, in the sense that I think if you're going to answer that question, you would want to say something about the fact that you need to generate tie points. This is showing the solution to the equation, but let's go back to the question, and I think I would start off by, again, you can use a flow diagram for this, just showing a block of just showing the processes that you would go through. So you would probably have a flow diagram that would start by, where would we start? We could, adjustment, it says bundle adjustment, I think, in the question, doesn't it? Let me just see what I would think of as being the start. Oops, I'm dropping it. Right, so interior orientation of all images. Then you would have another block where you would then start to be talking about generating image pyramids. Then you would have another one that would be coming down to be I'm doing this fairly quickly so I don't take too long to apologise, it's a little bit scribbly. You observe the ground control, then you would have